It says it's live. I mean, this thing thinks it's live. Oh, now we are. Okay. Now we're live. Don't know what happened there. But welcome to Climate Chat. I'm your host, Dan Miller. And today we're going to be talking about a form of geoengineering, space-based geoengineering, with Ross Centers, who's a board member and co-founder of the Planetary Sunshades Institute, and is also the CEO of Ethos Space. We'll talk about that as well, which is part of this whole thing. And he's an expert on how can we cool the Earth by putting a sunshade between the sun and the Earth, which sounds like a wild science fiction type of thing, which I guess it is to some degree, but it also can actually be done if we put our minds to it. So before we get started, please like and subscribe so that more people can hear this message and learn about climate change and the problems of climate change, as well as the solutions to climate change. So please like and subscribe and leave a comment as well. What do you think about solar geoengineering? What do you think about the planetary sunshade idea, et cetera? So Ross, welcome to Climate Chat. And maybe you could start off by telling us a little bit about your background. How does someone sort of get prepared to explore the world of planetary sunshades?
Yeah, thanks for having me, Dan. This is a wild idea that I have been pursuing for about 8 years. And the story of how we came to found the Planetary Sunshade Institute, and the sort of seed to our growth, it actually started in 2015. So in December of 2015, SpaceX landed the first reusable rocket, the first Falcon 9 landing. And at that point, I gave myself permission to start working on what was clear to me that was the next keyhole behind rapidly and fully reusable launch. And that's going to other planetary surfaces and using the resources there to build larger things than you could ever build on Earth in space. So I ended up at the Colorado School of Mines right when they were forming a research group in space resource development, right? So it fuses planetary science with mining engineering. And when you look at this technological space, you realize that markets drive everything, because that's mining engineering 101. What's your product good for? I was thinking about climate change a lot, as we all are. And I had an idea, like many people do, that like, hey, maybe you could just put a big shade up at Sun Earth L1, and I'll go into the gravitational dynamics of that. And then, a lot of people then do a literature search and find out that it's not a new idea. But as of 2018, when I started taking this idea seriously, there wasn't much going on in the field. And so I felt that this was, a really important concept, and we were probably going to need it someday. And so we organized the Planetary Sunshade Institute. And what we have found over time is that the time frame for doing this seems to get closer and closer, and the feasibility of it seems to get closer and closer, right? So, you talk about science fiction, and it is, right? Like everything is science fiction until somebody builds it. You've got a great 2001 poster right behind you, right? In the 1960s, like right now we're teleconferencing, right? Like this was science fiction in the 1960s. In the 1990s.
It was in 2001 specifically, by the way. There was a scene of that in 2001.
Exactly that, right? Like he calls his daughter on a video call from space, right? And then by the 1990s, AT&T or Pac Bell, somebody had picked it up as corporate advertising about the coming future, and here it is, and we do it all the time without remark. So yeah, I happily embrace the moniker of science fiction, but we're doing hard engineering behind this, and there is hard science behind this. This is a very real project, and we think it's critically important.
That's great. So maybe you can walk us through the basics, like how big does this thing have to be? How much does it weigh? How much sunlight has to be blocked? What is L1?
Yeah. Let's walk through the basics. So, first of all, I know this is a sunlight reflection mature audience, but let's talk about what it is and why. Okay. Earth is heating up. It's heating up because we're pumping too much greenhouse gas into the atmosphere, and it just stays there on the order of centuries, millennia. And that's a problem, right? So most of the conversation focuses around controlling our atmospheric composition, somehow pumping less greenhouse gases into the atmosphere, which we should do, but we're not. We're pumping more. or somehow pulling those greenhouse gases back out of the atmosphere, which we could do, but would require surplus clean energy and on the order of 100 years to move on the order of 1 trillion tons of carbon back into the ground. None of that adds up, right? As I think most of us here on this show know, like there isn't an outcome where that leads to a world which has a recognizable climate, anything close to 2 degrees warming. So the other way of managing Earth's temperature is to control the amount of energy coming into the system, right? So the reason Earth is warm as opposed to an icy cold ball is because the sun heats us. And the sun, if it happens to be just a little bit dimmer, almost within range of the variability of dimming throughout geological history, for instance, if you dimmed it by maybe 1%, that would even out the energy balance for the greenhouse gas heat retention. And in doing so, we could, in theory, control global temperatures. This is an idea that is not at all new. I sort of mark James Hansen's testimony to Congress as the beginning of global warming awareness, at least in the United States. And just a year after that, in about 89, 91, this stuff was happening. James Early at Lawrence Livermore published a paper on L1 sunshade to reverse global warming. And it was a beautiful paper, like 2 or 3 pages. He put together 80% of the theory for this. The theory is simple. There is a serendipitous gravitational point about 5 times away farther than the moon, 2.3 million kilometers, called L1, where you can park a sunshade. So any structure will sort of stay there with minimal station keeping effort. And that means you can be on the sun-Earth axis 100% of the time. And so if you scaled it up to the point where, if from Earth, if this is our view of the sun, if you had a sunshade that was collectively shading maybe 1% of the sun, you would be able to effectively dim that amount of energy hitting Earth. And you'd be able, by controlling its size, to control the total energy balance of Earth. So that's the first order logic of it. That's 80% of it.
And I guess we should say that the reason L1 works is because it's where the sun's gravity cancels out the Earth's gravity. So
that's exactly correct, right? Yeah. So that's a very serendipitous feature of physics in our solar system, right? People think abstractly of mirrors in space, but space is a physical domain, and in space everything is orbiting. So because we have these Lagrange points that allow us to park things between 2 heavy bodies, it's possible to build a sunshade in a way where it would otherwise be very, very difficult. So nature favors this solution. Its size is large. It's in order to block about 1% of the sun, it's going to have to be a few million square kilometers. It's very, very large. Is
that the size? I heard somewhere the size of India. Is that right, or something like that? Or
Greenlandish? Yeah, like very, very, very large. Its mass is not that large. It needs to have some mass, otherwise, essentially, it gets blown away by the solar radiation pressure. But if you make it of, say, aluminum foil, this stuff here has about the right areal density. And the total mass of a few million square kilometers of this aluminum foil is on the order of tens of millions of tons.
By the way, has anyone ever looked up how many square kilometers of aluminum foil is produced every year?
I have. It's about a decade's production of aluminum foil on Earth. Oh. So essentially, I mean, and I love that we're just sort of diving right into the logistical problem of this, because that is the real issue of the discussion. It's essentially relocating the aluminum foil industry to the moon and boosting the aluminum foil off the moon. And the reason you have to go to the moon is that you just can't launch this much mass from Earth, practically speaking. And you wouldn't anyway, because
even with the new starships and things like that.
Yeah, it's like borderline possible. I mean, if you take, sort of Starship's goals is, 10,000 flights a year, 200 tons of flight, that's 2 million tons a year to low Earth orbit. And then you have to boost yourself all the way up to L1. So, by using the entirety of the Starship fleet at the entirety of its intended use rate, you could potentially launch enough sunshade elements to low Earth orbit and somehow get them to L1 to build it in a couple or a few or several decades. The reason you wouldn't do that is that if you're launching 10,000 Starships a day, there is no future in which you're not going to the moon to build a resource base to get further materials to get them outside of Earth's gravity well, right? So the reason for
You
that
should
is that,
explain maybe why you want to do this from the moon. Yeah.
yeah, exactly. So getting off of Earth is the hardest thing in space. Like getting off of Earth is almost physically impossible. And because of that, your mass ratios are really low. Like a fully loaded up starship mass is like 5,000 tons, and the payload is 100. They want to be 200 tons. It's not a lot, and you're punching all that mass through the stratosphere on a pillar of conspicuous combustion, and then you're re-entering that ship on a flame of plasma, which is hot enough to cook your nitrogen into all sorts of nitrogen oxides, etc. It's an impactful, expensive, and difficult maneuver, right? So they say that amateurs talk technology, and professionals discuss logistics. The logistics of any production of things in space involves getting everything past that launch bottleneck, right? That launch bottleneck from Earth is the problem. And so if you optimize around that bottleneck and trying to maximize your impact off it, what you realize very quickly is you want to send not your product into space, but you want to send the factory that makes your product into space. And in order for the factory that makes your product to go into space, it has to be optimized around working with the raw materials that are in space. And the raw materials that are in space are well understood. The moon is a very boring geological body.
Mhm.
This is lunar regolith, and it's just kind of a uniform ore body, and we
Simulated,
know
I'm
how to work with it.
assuming.
Simulated, indeed. We get it from Greenland. But the moon and the Earth were originally the same thing. We came from the same protoplanetary collision. So we have the same rocks here and there. It's just the Earth has undergone a lot of geological differentiation that the moon hasn't. So once you get past Earth launch and you get to the moon, what you have is a gravitational well that's 6 times shallower. Getting out of a gravitational well is an exponential cost. So it's at least 20 times on an energetic basis cheaper to get off the moon than it is to get off Earth. You don't have an atmosphere to deal with. You don't have an environment to deal with. You have the ability to ignite unlimited growth. And that unlimited growth ignition point is where you start to be able to foresee really exciting outcomes. Like, for instance, not just a planetary sunshade, but essentially infinite compute for AI in space, which is what SpaceX's IPO and pivot to the moon is all about. And if you look at that, the base of it is Starship. And yes, they're going to launch data centers in space. But the real scaling play for it is to build a moon base and to start launching data centers built on the moon into space. And SpaceX talks about launching petawatts of compute into space, and a petawatt of compute takes up about the same surface area as a solar cell collector that a planetary sunshade would. So we're right within the realm of what people are actually talking about doing, and what is better capitalized than any company in the other.
So we can get back to the logistics. So I still want to understand, because there's different, as I'm sure everyone who's listening knows, there's multiple ways we can cool the Earth. I mean, we had the mirror group on here. You can put mirrors on the ground. You need a lot of mirrors to do that. Um, there's ways to brighten clouds. There's nanobubbles can cool the oceans. And then, of course, the main way that most people talk about it is what's called stratospheric aerosol injection, where you put sulfur particles or other particles in the stratosphere and they reflect the sun. And that's something we can do soon. It does take a couple hundred specially designed airplanes and whatever, and a lot of logistics, but very cheap and easy compared to climate change and certainly compared to space-based SRM. So let's take a look a little bit about, like, what are the fundamental differences. Let's take SAI, stratospheric aerosol injection, versus a planetary sunshade. They don't really cool the Earth the same way. So maybe you could talk about the pros and cons of each one.
Yeah. I mean, first, let me talk a minute about why SAI and a planetary sunshade are the right things to compare. You could put mirrors on the ground, or you could, alter the reflectivity on or around the oceans. Those things sort of push heat around the Earth system. You can cool areas that way, but you're going to create follow-on effects.
Yeah.
If you want to have a restorative impact, you need to cool the entire sunlit hemisphere on a reasonably homogeneous basis. The only domains that you can affect that intervention in are the stratosphere, which is a homogeneous layer of atmosphere, or deep space, which is outside the system altogether. So stratospheric aerosols versus a planetary sunshade do very much the same thing in different ways. If you seed the atmosphere with stratospheric aerosols, you're increasing the reflectivity of the atmosphere, and you're going to get a diffuse light reflection. And that, you know, climate models show that the benefits of that are way, way better than the risks. A planetary sunshade effectively reduces the solar constant by a little bit. And we have the ability to bias that towards polar shading, which is good for a climate outcome, but that's down in like the 20% details. 80% vision, you just dim the sun a little bit. It also looks from the early fully coupled climate models we've been doing that is also something that has much better benefits than risks. And I characterize them as, while differentiable from SAI, I think the most important thing is that the effects are linearly substitutable. They're almost the same thing.
Really?
And that's a good thing. Yeah.
Because I've been reading about this. And one thing that SAI can do is you can preference the poles.
Yes.
So, for example, you can, the Arctic, for example, is warming much faster than the rest of the Earth, and so you could focus on that. Now it is going to spread, but as you keep replenishing, there's going to be stronger cooling there versus the tropics. Whereas a planetary sunshade is just equally dimming the Earth across the entire globe, and therefore let's see, the tropics can cool more than they should, and the Arctic can cool less than it should. Isn't that right? I mean, there's a pretty fundamental spatial difference, isn't there?
No, that doesn't have to be true, and that's actually the focus of most of the research we've been doing at the Planetary Sunshade Institute is how do we propose a baseline architecture that accomplishes that polar shading bias in a way that was illustrated first in a 2015 paper by Sanchez and McInnes, but that we're following up with fully coupled climate models and a baseline engineering architecture to implement that intervention in a logistically reasonable way. So, I mean, the way it works graphically is, here we are. Let's call this asteroid our sun. And the sunshade, let's make it a monolithic thing instead of a swarm, is just at the tip of my pinky, right? And here we are at the equator, right? Now, if the sunshade was boosted towards celestial north a little bit, and we're at the equator, and then we see the sunshade on the solar disk a little high, if we moved ourselves up toward the North Pole, the sunshade would actually be off the solar disk and just shading the southern hemisphere, right? So by boosting this thing on a slightly inclined orbit, you can cast these shade cones a little bit. And now I need another ball. I don't have another one here. Okay. Make the fist of the Earth, right? You can cast these shade cones by biasing the sunshade north and south towards the polar summer.
So there's multiple sunshades.
Exactly. It's always a swarm. A monolithic structure.
Of sunshades. Okay.
Yeah, a monolithic structure that's 1 million square kilometers is probably infeasible, and there's no need to have it. So sunshades can maintain station keeping by solar sailing. They're satellites. They sort of tack and move against the solar radiation pressure, and by using that, they can implement collision avoidance in the L1 vicinity, and they can use that same control authority to get polar shading biases. But looping back to SAI and the complementarity to sunshades, a sunshade intervention is rather slow, clean, and expensive compared to an SAI intervention that might be considered fast, dirty, and cheap. And in any realistic deployment scenario, we should be doing both, right? It's important that we develop both of these technologies. And I'd be really happy to make a strong case for that if you want to take a few minutes for it. But SAI could be polar preferential, and you could start building out a sunshade that's entirely equatorial. And then as you build out that sunshade fleet, you could move that components of it towards polar biasing and completely take over. But the interplay and the ramp is very interesting.
Yeah. Well, one big issue, two big issues. Let's now just assume that we can do it. It's going to be very hard, but we can do it. So one is, how much will it cost versus, I mean, estimates I've heard for SAI are $5 to $10 billion a year, which is nothing compared to the damage of climate change, for example, of it trillions of dollars eventually. So, and then the other one is, well, we can't do it right away. We haven't tested it enough, but talk about a decade or so if we got serious about it, something like that. We could even test it much sooner than that. So how much would it cost, order of magnitude, and how long before, assuming we get serious about implementing this, we start researching it and developing it, how soon could we have this?
Yeah. I mean, so SAI, we could have it tomorrow. You can make a strong argument we should have had it yesterday. It costs tens of billions a year, and that expenditure goes on essentially forever, because we're talking about a century plus of intervention. A sunshade, so you could, instead of spending tens of $billions a year forever, you could argue that maybe we should spend $1 trillion once and build a self-sustaining, sustainable sunshade. If you take that $1 trillion as just the equivalent cost, that gives you a cost per kilogram for a sunshade that masses 50 million tons of $20 a kilogram. So if you can hit a lightly machined material in space target of $20 a kilogram, then you can build a sunshade for $1 trillion. And if SAI costs tens of billions of dollars a year forever, then it's certainly worth at least $1 trillion.
And that includes,
so the economics aren't the problem.
Includes the moon base and everything?
I mean, fully amortized.
I think a moon base sounds like $1 trillion thing to me, but I could be wrong.
This is one of the things that I've been encouraging people to imagine more about for a long time. But in 2026, we don't have to imagine it, right? Like SpaceX's IPO is intended to create a moon base that is intended to chuck petawatts of power into space. Like we are getting the logistics for a sunshade for free. One thing that I think you need to think about when you're talking about, megaton scale activities in space is that these things are largely robotic and self-sustaining, right? Like that's the technology drive there. So it's mostly your initial investment. After that, it's not like there's salaries to pay for people swinging hammers. You're trying to create a system that continually operates and produces useful goods. So it's pretty much all CapEx and not OpEx.
Yeah. Now, I don't know if you saw this recent paper speaking about all of this. Is not really directly sunshade, but it's about petawatts of power in space and data centers in space. That there's a new study that says that satellites re-entering the atmosphere burn up, and their aluminum oxides and everything get in the atmosphere, and that is potentially can destroy the ozone layer. And that and there's like a 20-year delay between when you do it and when it really affects the ozone layer. So we've already put enough space Starlink satellites up there to really cause a lot of damage, and to go to the next step of power, because these things are going to re-enter the atmosphere. They're low orbit. That's when
you're looking at environmental impacts, you got to compare it to natural baseline, right? And the number's not right off the top of my head, but I think it's on the order of like 1 million tons a year of natural meteorites re-enter Earth's atmosphere. That happens. As long as you're not really.
No, they talked about that and compared it and said the satellites are way more. And it was because of the kinds of metals. It's kind of meteorites. If they're stone, that's one thing. And if they're iron, but there's not a lot of aluminum coming through, and it was like specific to the kinds of metals. It was not a show on that. It's just that, I guess by the way, the general point is, and this is why we have climate change, is we typically get excited about technologies like, oh, fossil fuels are great. Look what they can do. And we don't actually think out a little bit about what the consequences are if we scale them massively.
Well, I mean, the greater point about space debris that you mentioned is that we shouldn't be doing this stuff in low Earth orbit. We shouldn't be doing this stuff in any way where it comes back to Earth, and we shouldn't be launching these materials from Earth in the first place, right? Like the point is we want to get an industrial and economic disconnect from Earth so that Earth can remain a place of a biosphere, that it's for humans and nature, and our precious planet doesn't get, absolutely turned over to industry. We do that by breaking the chain and by doing things sustainably in space, orbiting the sun, not orbiting Earth.
So get back to the main thing here. So you said about $1 trillion, which again, in the overall scheme of things, is cheap compared to, by the way, the amount of CDR, carbon dioxide removal, we have to do to stay safe, is to draw down the excess we've already put up there. That's on the order of $1 trillion to $2 trillion a year. So $1 trillion for the cooling would be kind of a bargain, because, as you said, that's over a long period of time. So just go down to the bank and get a loan, and write it. But talk though about the time frame.
Sure. So what there's two branches to the time frame. One of them is technology, the other is logistics. Logistics is the hard part, but let's talk technology first. We believe at the Planetary Sunshade Institute that there should be a baseline architecture, which is public, open source, of how do you create a free-flying solar radiation management sunshade element. That can be constructed and launched from low Earth orbit, subscale demo, very much analogous to what we're talking about in terms of like looking at plume dynamics with SAI. We are beginning to shop a proposal for a frontier research organization that will do that. So a series of launches beginning 2029, 2030, going for 5 years, culminating in a fully mature L1 sunshade demonstrator, showing that you have control authority, showing that the sunshade free flyer works, showing that a machine that you build from resources you could get from the moon could indeed be operated like this. So that's an important part of demonstrating
How big would that
feasibility.
sunshade be, for example?
The demonstrator need be no bigger than 100 meters.
Okay.
A mature sunshade element in our reference architecture is looking like 40 kilometers across. And we need about 5,000 of those. So now you're talking logistics. Now you're talking scaling up. For doing that, you need a moon base. About 10 years for a moon base. I think we're 2035. We're looking at the ability to start really developing at scale and beginning to export materials off the moon.
2035?
2035 is
9 years from now?
I think 9 years from now. Yeah. I mean, there is a lot of energy behind this. And it's not going to be government driven. It's going to be commercially driven. There's a race to put as much energy in space as you can for the purposes of compute primarily. And that logic drives you towards building a moon base to create solar panels, silicon, and aluminum radiators from lunar materials. That's happening. And on the other end of that, we're going to have the capacity to start throwing sunshade elements up. Build out of a sunshade, about a decade. So bull case, moonbase 2035, sunshade substantially in effect 2045.
Wow.
Yeah, it's totally achievable. Now, sure, there's technology elements that have to happen. Like that's a full tilt boogie. That's the equivalent of getting SAI up in 2 years. But we could get SAI up in 2 years if we wanted to, and we certainly haven't performed like that in the past. Again, SAI and sunshades are incredibly complementary technologies. We should be pushing on both. Our climate security is going to depend on some sort of SRM for a century or more. And there's only 2 ways of doing globally hemispheric cooling. So the timelines are complementary and they cover each other.
Well, one of the challenges for SAI is actually, well, there are multiple challenges, but one is the technology and how do you deploy the sulfur and mix it in the atmosphere? There's that kind of thing. But also the big one is understanding when and where and how to deploy so that you have a positive impact. Maybe you prevent an AMOC collapse, for example, that kind of thing. And we've had Doug McMartin and Daniel Lencioni and others on to talk about all of this stuff. Yeah. But what about the state? When I see research on climate models, dealing with SRM, usually they're SAI models. How much work has been done to model the impact of planetary sunshades on the climate?
So Dan Visioni did some published in 2021 on planetary sunshade effects on the climate. It's good. It's comparable to SAI. We are very happy to be working with him on a ARIA-funded research grant from the UK taxpayer, to whom we're grateful. And we're doing more fully coupled climate runs on sunshades, including polar preferential sunshades, and also including the possibility of spectrally selective sunshades, which could produce a radiative antidote to CO2. So the modeling looks good. As expected.
I mean, be selective in which rays you block, so you're only. Let's see, what would it be? But the CO2 is the long wave coming out. It's not the short wave coming in. So you can't be
correct. Yeah. So there's a paper by Seeley et al. About 2020 proposing an algorithm that would allow you to design a wavelength selective intervention that would allow you to essentially serve as a radiative antidote to CO2 and to balance that radiative forcing at all levels of the atmosphere. So we've done some work with the University of Nottingham about designing a specific spectral window and designing a metamaterial that could implement that selectivity. And we're looking at we have done some early work on the climate modeling of that, and it's very encouraging. Residuals are lower. It's a great technology. It's not necessary to have that technology to make sunshades a good idea. Like an opaque sunshade is a good idea, just like SAI is a good idea. There will be better ideas over time, but the point is that we should make something manufacturable with technology we understand right now, right? So the work of the Sunshade Institute is to articulate how the world can build a planetary sunshade rather than what the possible space of anything is. And so we're really focused on creating a baseline architecture that's very, very simple. And so we're looking at everything, but I just want to underscore that this is something that could be done in a very dumb way, right? We can make this out of aluminum, which is 14% of the aluminum of the lunar regolith. But later on, we could do spectrally selective.
How long can this one of these machines last in space? I mean, it's being hit by cosmic rays continually and radiation from the sun and heat stress and street heat cooling. That we look. Is there any estimates of how long it could last?
Yeah, when you look at like polymer, like super light, super thin solar sail technology, you're looking at decades. But a sunshade actually has to have mass. Like if you make it too light, you'd have to add ballast. So if you baseline like a 7-micron aluminum layer with ripstop in it, mechanically you're looking at an indefinite lifespan. Yes, it gets punctured, but that puncture rate is low and doesn't propagate into large tears.
But the control systems and things, I mean,
the control systems, yeah. So that's part of the reason that's a constraint for our architecture is how do you have redundant and replaceable control systems. So the way we're looking at building a flyer is if you have control all actuated by redundant cables, which would take on the order of a century to start having systemic failures there. And then the actuators behind those cables are actually concentrated in a hub that fits within a Starship fairing and contains replaceable units that could be serviced on orbit easily.
So within the hub of a thing, and the thing is this. Oh yeah, so
it spins.
I guess you need the size of India overall, but that's multiple planetary sunshades. How big would one planetary sunshade be, and related to some geography on Earth, perhaps?
Yeah, we think the optimum diameter is about 40 kilometers. So think of like the LA Basin.
Bay Area,
the Bay Area. Yeah, about 5,000 of those. So we have a heliogyro architecture that we're about to publish. I just got back from a.
So how big is this swarm?
About 5,000 of them.
Oh, okay. I saw one of your lectures and you showed 5. So I was in my head, I was thinking 5.
It's hard to show 5,000 on TV.
Yeah. Okay, I see.
Yeah, and each one has 500 blades as opposed to like the 40 or so shown. But this looks like a really doable architecture. And the cool thing is it's 99.96% lunar mass.
So I think I know the answer to this one, but let's talk about some of the objections to solar radiation management in general. One of them is termination shock. So you use this to cool the Earth. Maybe we didn't do as good a job as we should have on emissions reduction and CDR. So it's out 20 years or something, and we're blocking 1-2 degrees of warming, and something happens out in space and screws up the system, and it shuts off essentially or turns away. How do you deal with that?
Yeah. So let's assume the worst case scenario that we as a civilization lose the capacity to build and sustain things in space, which is not that far out. We've almost lost it in our lifetime. That's one really strong argument for why you want SAI.
I know that. Yeah.
Right. So, I mean, but short of a catastrophic event, this thing has a pretty minimal risk of termination shock because the relative orbital velocities around L1 are very slow. There's not a lot of risk of Kessler impacts or degrading your environment. Things move very slowly out there, on the order of walking speed relative to each other. Control should be pretty sustainable. So, I mean, yeah, termination shock is always bad, but that's why you want at least two major systems. That's why you want SAI and a sunshade. Consider alternatively the risk of termination shock with SAI, right? Like what if for whatever reason.
Yeah, well, that one is well known, right? You just stop flying the planes and it goes away.
So, sunshades are an answer to termination shock for SAI. SAI is an answer to termination shock for sunshades. It's redundancy. That's how you build security.
Yeah, I like that. And So let's talk about the other one, since you must get these all the time, and I think they're worth talking about. See, the other main objection, well, I guess there's 3 or 4. Moral hazard. You put this sunshade up, hey, we don't have to cut our emissions anymore. What's your answer to that moral hazard issue?
How's those emissions cuts going? How are we doing?
Say again?
It's a question. How are those emissions cuts going? How are we doing?
Yeah.
Right.
I mean,
Like,
to
what
me,
moral hazard?
my
Like,
answer is always, oh, what you're telling me is that we're not going to take climate action seriously. You're going to let the fossil fuel companies do what they want to do. Is that what you're telling me? Yeah, because if you choose to fail, you do.
Yeah, I mean, we've all heard the argument, like the idea that, oh, if we have some sort of remediation of the effects of climate change, then we won't be like inspired to solve the problem at the root cause. It's a terrible argument.
Yeah,
we're not solving it at the root cause. We're not doing it. It's just not happening. The transition away from fossil fuels is technological. It's not political. It has almost nothing to do with moral urgency or anything. And the real moral hazard is, what if we don't develop technologies that can spare the earth from the worst effects of climate change because we're having a quest for moral purity? Like, what's the morality in that?
Yeah.
I don't think anybody who seriously articulates that argument is at all acting in good faith.
Yeah. And I think the other one is that you're asking the global south to suffer so you can encourage the wealthy north to try to cut their emissions more, or something like that.
I mean, look, here's what it really is, right? We have two orthodoxies, at least here in the West, right? We have a left-wing orthodoxy that says that we're going to degrowth ourselves and we're going to redeem ourselves by purging ourselves with technology and return to some state of nature in which, everything is just and everything is in harmony. And then you have another orthodoxy on the right that says, no, we're just going to do what we're going to do and ignore the problem, and it's not a problem because human triumph in industry and ingenuity, right? Geophysics doesn't care about either of those, right? The geophysics just doesn't care. It's getting hotter because we're emitting carbon. And if whether we're emitting carbon because we are failing to be virtuous enough to not emit carbon, or whether we're emitting carbon because we just don't care, the geophysics doesn't care. So we should be operating primarily on a geophysical level to stabilize this system for humans and for nature. Because there's only dozens of us working in this field. The fossil fuel world and the emissions mitigation world, they're huge. They have so much inertia. Nothing's happening on a political basis. Don't preach to us like our potential solutions are somehow morally invalid because they conflict with the grand war between fossil fuels and emissions reduction. It's just not helping.
Yeah. Yeah, I agree. I'm throwing these out because
it comes up every time.
Up all the time.
But it's important to have a forceful defense against it, right? If you look at what happened to the nuclear industry, it was very apologetic, right? Nuclear is very apologetic. Oh, we're going to really focus on mitigating these dangers. We're going to really take all of your arguments in good faith, and we're going to respond to them in good faith. But the arguments weren't being made in good faith, right? The arguments were being made in order to shut down nuclear power. It was absolutely transparent that the goal was to fight nuclear power, not to have a dialogue on how to have a safe outcome. And the whole impetus of just stopping things from happening, it doesn't lead to good outcomes. When you stop things from happening, something else happens. And we stopped nuclear power from happening in most of the West, and instead we got coal burning and fracking, right? It'd be really instructive.
8 million people a year.
Yeah. I mean, it'd be really instructive to look at how France managed to move their society towards sustainable nuclear power. If we had all been like France, we wouldn't have this problem in the first place, right? But Greenpeace, for all their good intentions, drove us to climate hell. Right. And if you look at the history of SAI going basically nowhere in terms of outdoor experiments, it's Greenpeace again shutting down Scopex, which is leading us further down climate hell, paved in good intentions.
Yeah, the whole show right there to talk about. Let's see. But the other one, and perhaps, I don't know, maybe the strongest argument, and I know the answer too, but is negative side effects.
Yeah.
So impact on agriculture, changing it, especially changing in monsoon pattern. That seems to be the big one. As if we're not going to have a change in monsoon patterns if we don't do SRM. SRM. So what's your response to the It's both known and unknown side effects.
Any conversation, any serious conversation, has to be rooted in a comparison between SRM and unmitigated climate change.
Correct.
That is the baseline. Any conversation rooted in a return to a pre-industrial, natural, late Holocene equilibrium is an invalid conversation. That future is not accessible to us. We don't even live in that present, right? So those arguments are either being made out of denial or in bad faith. And if they're being made out of denial, I have a lot of sympathy, and like we have to talk about like the stages of grief and coming through that, which we all have gone through before coming into this field. But if they're made in bad faith, like it needs to be called out. Like it's totally wrong. So unintended consequences. Basically, I think the biggest shorthand answer to them is that yes, there are large uncertainties in what happens under an SRM world, but those uncertainties are smaller than what happens under an unmitigated climate change world. And the reason for that is intuitive. It's because the uncertainties are driven by climate feedbacks, and SRM interventions suppress the feedback cycles that cause those uncertainties. So, yeah, are we dealing with risk? Yes, we're dealing with risk. Does the science show that the risk is manageable and is better than the risks on the other side of the table? It looks like it does. And so, I think we should proceed on that basis, and that would argue for cautious and informed move towards developing a deployment option for politicians to take when they're ready.
Well, so I did the whole show on the trolley problem, and this is this is the best example of the trolley. But for those who don't know, the trolley problem is a sort of a mind experiment. There's a runaway trolley coming down a track. You're walking down the track, and you're by the switch that can switch the track from one track to another. You look on the track the train is going to be on, and you see there's 5, 10, 100 people tied to the track. You can't get there in time. The train's going to run them over and kill them. But if you throw the switch, it'll go down another track. But you see down that track, there's one person tied to the track. So the question is, do you actively throw the switch, and you are now responsible for that one person dying, even though you saved 10 or whatever the number is? And this is sort of the same thing. People seem to be far more upset about actively well, of course we are anyway, but I mean, I don't know what purposely I should say, changing the climate versus accidentally changing the climate. Any thoughts on the trolley problem and how we get around that mindset?
I mean, so it's very much rooted in human psychology that the sins of omission are qualitatively different than sins of commission. I think you just have to respect that as something that is not like geophysically rooted, but is politically real. We got to talk about the decision we're going to make and how hard it is. And in order to do that, we have to talk about what are the benefits and what are the risks, right? If the entire story about the trolley problem is about this one hypothetical person, right? You're just encouraged to make it more and more vivid to the point where you're looking at like weird, almost unreproducible issues in models and saying, oh, it's going to be that, right? Like we don't have models that can tell you exactly what's going to happen to the monsoon in this province in this year. Like that is in the noise, right? We know things are going to get generally better. We know that overall lives are going to be saved. We know that almost everybody's going to be better off. I think you got to focus on those 50,000 people and make the story vividly about that so that we can make that decision to do the right thing for the environment, for communities, for ecosystems, and for humanity.
Yeah, although I don't know, you sound like you're asking us to be rational, and that I'm not sure. We haven't been so far. In fact,
reality will have its way with you eventually.
So
yeah, like I am asking us to be rational. Like, and if we're not asking ourselves to be rational, then we're just rolling over and dying, right? Because anyway, reason is our only tool. We're imperfectly rational. We try to do a lot of stupid things before we eventually do the smart thing, but reality keeps rejecting all of our stupid efforts. And when we do the smart thing, reality will accept that. And you just have to have faith that the universe works that way.
Yeah, well, that's what this show is about, is try to present climate change and both the dangers and solutions in a rational way. So, besides being, I think, a co-founder and a board member of the Planetary Sunshade Institute,
Correct.
you're also, I think, co-founder and CEO of Ethos Space. Is that right?
I am.
Yep. And
Yeah.
you got the sign behind you. So tell us, this is all tied in together. Tell us what Ethos Space is and does.
So Ethos Space was founded to provide the logistical heft to make construction of a planetary sunshade possible. We have been working at it for about 4 years now, and we have successfully turned lunar regolith into useful materials like landing pads on the way to propellant, silicon, and aluminum, all these base things. We're a LA company. We're venture funded, and we're really excited to see that the market for compute in space is blowing up, and that the question of how large is our market size is looking to be a TAM that is potentially larger than terrestrial GDP.
Wow. I'll tell you a quick story about lunar regolith. I used to teach astronomy, like a volunteer astronomy teacher in sort of some schools in Oakland, and so for that I borrowed some actual lunar samples from NASA, encased in plastic and everything. You could hand it around and let people see it, and you could not let it out of your sight at all unless you had a special safe, which I did not have that kind of safe. So I had take it to the bathroom. You had to sleep with it and everything. So I had it for a week, and it was fun. The kids really got a kick out of seeing real moon dust and things like that. But I was so happy when I sent it back. It was like it was kind of fun at first, but then when you really had to go everywhere in your life with this thing, it was not as much fun as it sounded. And that was the real stuff.
It illustrates the transition from exploration to industrialization, right? These exploration products are precious and irreplaceable. Industrialization is a commodity thing, right? Like every time you cruise around with Starlink internet, you're using, industrialized space, and pretty soon you're going to be using industrialized moon.
So, first of all, great discussion so far. It turns out that one of our co-mods on the channel, Eli Rabani, is a scientist studying planetary sunshades. I believe you know each other. And so I want to bring Eli in here because he has a set of questions for you as well. Okay, so let's bring Eli in and welcome Eli.
Hi,
Eli, good to see
thanks. Thanks, Dan. Good to see you again, Ross. A few things. There are proposals for types of sunshade which wouldn't require any fundamental breakthroughs at all. But from everything you've looked at, are there any basic scientific or technological developments which could be researched now, which might advance progress towards a real sunshade sooner significantly?
No, everything we need is here. Nothing major. There are some engineering breakthroughs that need to be done. I'd say engineering advancements. Like we need to be able to, stabilize solar sails and actually navigate with them, and maintain planarity at very large apertures. That's why we have a spin stabilized architectures we're looking at. We need to finish doing the electrochemistry of purified material production from lunar regolith, which is what we're working at Ethos. None of these things are different from just other basic industrial R&D stuff. So I say no though, because there's no profound gap here. There's just a bunch of little things that need to be closed that will yield to reasonable and well-timed investment.
Good. So if you could change just one thing, you have a magic wand that you're granted to make a sunshade a reality sooner, a full-scale sunshade a reality sooner. What would that be, and how much sooner could we have a sunshade making a noticeable difference?
The economics of mass logistics in space is something that people need to understand. Because you're optimizing for mass flow through the launch bottleneck, and because you have to assume the launch bottleneck as being somewhat fixed, your figure of merit for growing an industrial economy of space is your mass return on payload invested. If you're thinking about seeding exponential growth in space, the function looks basically like the base of the exponent is your launch capability, and the exponent is your mass return on payload invested. If people understood that question, they would understand why lunar resource development is just the no-brainer that changes everything.
Okay, I totally agree. In the long term, lunar manufacturing makes sense. I, on the other hand, have a different view of how precarious our situation is, just because of the uncertainties in feedbacks. You know, we went a couple of years ago from equilibrium climate sensitivity being taken to be 3.5 watts per meter squared by the IPCC, and it's looking more and more like it's really 4.5, which means that even though, you know, Trump declared the bad scenario, the business as usual scenario, dead, right? It turns out that the scenarios which are still very much alive are going to be just as bad in terms of the way the Earth climate system responds. So say we had a budget that was the sum of the Apollo program and the Manhattan Project, and in 2026 dollars, that would be about $345 billion. And we had 5 years. That sounds like a lot, but it would only be 0.055% of world economic output for each of those years. How large a sunshade could we deploy, and how much of a difference would that make to the climate? Just
In 5
your gut.
years,
Your gut, yeah.
give 50 billion to SAI and put 300 billion into lunar resource development. I am so glad we have SAI. Like, I cannot promise any sort of climate effective sunshade in 5 years. There's no, you're just asking for magic. If we had the political will to affect climate intervention now, deploy SAI now, right? Like, the most disappointing thing to see is how slow progress is going in that field. But that could be turned on a dime. Sunshades are a legitimate logistical heft.
I don't. So that makes me think of a question like, where do you see in the long run the balance? Do you instead of 5,000 sunshades, maybe 2,500, and then the balance being SAI? How do you know, once the planetary sunshade is working?
Yeah.
What do you see between that and SAI, the split?
Here's the correct way to think about the next century, which should start yesterday and could have started yesterday. Start pre-deployment activities of SAI now. Learn about that, ramp it up if it proves safe. At the same time, launch technology demonstrators for Sunshade, like the Planetary Sunshade Institute is proposing doing. At the beginning, your intervention is going to be essentially 99.9999, basically 100% SAI, and just, you know, a demonstration of Sunshade. Sunshade ramps up over time, and over time it becomes 100%, because eventually we'll be able to do, we'll have the mass up there to do polar selective. We'll be able to potentially do spectrally selective. I think sunshades overall are a marginally better geophysical outcome than SAI, and it's certainly politically better and more exciting.
Okay. And Eli, do you have further questions there?
No, that covered it. Though I look forward to talking to you about some technical things later.
Okay, great. Stacy, are you ready to go? Oh, and here we go. Let's bring Stacy in. I don't want to be that one. Here, let's bring. There we go. Hey, Stacy. Oh, well, you have to go to this view so that we can see the cats. Ross,
Just one right now.
we try to increase our viewership by having cat videos on top of talking about planetary sunshade. So,
hello, Stacy. Hello, cats.
Hi, Ross. So glad to have you here. It's been a very interesting conversation, and I have been so pleased with all the people. I guess you guys met at Climate Week. Is that
yeah, we did.
okay? The people that Dan has had on from Climate Week, because it's like, yes, okay, these people get it, as opposed to some people that it's just like, you really think that's going to work? You really think? Whereas we need this type of solution, and it's good to hear that you're working on it. the one thing I wanted to throw in there is when you guys were talking about the ethics and the trolley problem, it's that getting people to care. It's like, because we're not the ones who will suffer the most. It is the people in the global south and our environment at large. And so getting people to care about them is that will be the biggest issue that we have, because people would change otherwise. Anyway, we had a couple good questions, and the one I really the first one I liked was that talking about, are you working with other countries? That if we're not talking with China, who will surpass our space capabilities pretty shortly, that it's not necessarily going to happen. I don't know. What are your thoughts?
So we're very much not alone in this. The Sunshade field is growing. It's not just the Sunshade Institute. I just got back from the first Sunshade workshop in the UK. There were 70 people there, 70 researchers from all around the world, predominantly Europe and the United States. We have research clusters in Italy, Germany, Sweden, the UK, the United States, and researchers all over the world. China is going to be a big part of this, to the extent that the construction of the Dimensional Sunshade will reflect the balance of power on Earth at the time that it is constructed. One really hopeful thing about doing this as a nonprofit and in public is that we're generally U.S. entities are restricted from discussing space technology with China due to arms control traffic regulations. But if something is published and open sourced, it is presumptively not subject to arms control regulations, for obvious reasons, because it's widely known. So we actually have the ability to work with China, and we'd be happy to have those academic collaborations at an appropriate level.
Yeah.
Okay.
I have a question about the moon. Is there an international regulations that I know you can't own the moon. Are you allowed to use and commercialize in a way the resources of the moon, like rocks and things like that?
Unequivocally, yes. There are two layers to the answer. One is the Outer Space Treaty, which everybody has agreed to since the 60s, which says essentially that you cannot appropriate the moon for national sovereign territory, but you have jurisdiction over your country's sponsored activity on the moon. And every space activity is sponsored by the country that launched it under the Outer Space Treaty. Under the United States Commercial Space Competitiveness Act of 2015, domestic law says that if you, as a private company, modify something on the moon, such as by making it into aluminum or another finished product, that thing is yours. And it also reflects back to the Outer Space Treaty principle of non-interference, which is nobody can interfere with your factory that is building those things. So national jurisdiction, property rights, 100% supported. This is also an interpretation that is supported by every Artemis country, which is a list that's over 50 countries and growing. Definitely not a problem.
Okay.
One thing that people were, I don't know, just kind of, they're hot. Some of our viewers in Europe are hot right now, and they're like, "Hey, can you bring a sunshade over there?" I mean, this is kind of a very pedestrian question, but could you do some sort of demo that would have an effect to cause shade in places? I mean, especially like in India, who gets hit very hard to reflect sun.
Yeah. Short answer is no. If you had something that was close enough to Earth to cast a regional or local shade, it would be in Earth orbit. And those structures are always moving around the planet, so you can't just park them over one place. That's probably a good thing. I maintain that doing regional intervention to the climate is generally not in a restorative direction.
But mainly because wealthier countries are the ones who would probably benefit from it, and not
when you do climate interventions with local needs in mind, and you don't intervene in the rest, you're going to alter precipitation patterns, weather patterns. You're going to have follow-on effects, in neighboring areas. And then those areas will be motivated to take their own effects, which will have follow-on effects back in your area and then in other neighboring areas. And you get into a really chaotically driven system, which is not necessarily an improvement from climate change, right? Well, I think the political goal that the world should be able to agree on is moving towards a restorative direction, where the way things were was better. If you just start opening the state space to any old direction, then you're actually talking about weather modification. And in terms of that, people do it, but there are, conventions and pressure against it, and you're responsible for attributable harms downstream.
So I have one here, though. This is how will you pursue?
That was my next one.
There you go. So
Yeah.
question for Rod. How will you persuade the players that have the skills, tech, money to establish mines and factories on the moon to build Sunshades rather than making money the usual way?
I'll give you the old answer and the new answer. The old answer is this thing is obviously in the economic interest of the public good, and states would eventually sponsor that construction. The new answer is SpaceX is going to do it anyway. Blue Origin stacked up behind them. Like Ethos is a startup in the space. Like this is happening for commercial regions, predominantly data centers in space, which are architecturally the same as sunshade elements. They're thin film structures with the hot side and the cold side. Sunshades are just another output from that industrial capability. So it's like, how do you, hate to use the war analogy, but World War II, we had car factories and then they started making airplanes, right? It's just a tooling change.
Okay. And by the way, if people are interested in what you're doing, and how can they get involved, or how can they learn more?
Yeah. Contact us, the Planetary Sunshade Institute, planetarysunshade.org.
There are links, by the way, in the video description.
Yep. Our executive director, Morgan Goodwin, is an excellent organizer, and we'll send you to the right place. There's a broad community of people all over the world, and if there's not a research cluster working on it in your area of the world, you can start one.
Okay. I'll ask you, since you focus so much on climate, and so here on Climate Chat, we talk about the dangers. We have the climate scientists on telling us how bad things are getting. We have people like you and others talking about solutions, but we also notice that we're not doing very much, like, on net, we're doing some good things. Solar's growing, but fossil fuel emissions are at an all-time high. Have you thought a bit about the psychological, political shifts that need to take place in order for us to start taking climate solutions seriously?
I think they're already taking place. People understand that we have passed a sort of a proverbial tipping point in this whole system, where just wishing to have fewer emissions is not going to put us to any place that we want to be. And so they're open to ideas. Our job is to develop and communicate those ideas so that they're not just hypothetical, not fleshed out science fiction in a pejorative sense, but rather so that they're fleshed out architectural roadmaps that can be executed, the proverbial shovel-ready projects that are science fiction in a roadmap sense. And these things have happened, right?
Yeah, I agree. I mean, to me, having worked on this for like decades now, the only thing I've seen that brought people around is like climate damage being viewed as climate damage, and we're having that now. Next year should be interesting with the super El Nino on top of climate change.
It just gets worse. We're also having a demographic shift where a greater and greater fraction of people are people whose entire lives, certainly entire adult lives, have been spent, being aware that climate change is real, being physically noticing the impacts of that, and knowing that business as usual has not gotten us to a fix. So it creates an appetite for, thinking outside, the ball in some sense.
Is there anything else we should know about Planetary Sunshades that we didn't ask you about?
I think that we covered it pretty well. It's the Planetary Sunshade Institute is focused on a coherent package of how do we produce a planetary sunshade. There is a lot of people, an increasing number of people throughout the world who are working on this. Our job is that we should all be thinking about how to make this more vivid and real for be developing towards a political action, and that we should very much focus this as a complement to stratospheric aerosols. We're very much pushing towards the same thing, and progress on one is progress on both.
Right. And one more
Dan,
question. Yeah, go ahead.
sorry. Yeah, Nevitz reminded me of one of my favorite questions when it comes to these type of discussions. Money, military spending. Have you been talking to any militaries, especially ours with the largest budget on planet Earth by not a small margin, about this for our own defense, especially since you spent some time in Colorado at near, I'm guessing, Space Camp or whatever it is, I forget, Space Force.
So no, the planetary sunshade is not a weapon. It is not a military system. It's not our role to be lobbying our military to take some sort of mission
just
that,
for their
our
money.
government hasn't given it, right? Yeah. There might be some ancillary technology development, but one of the things that is great about working with the UK's ARIA is that it's an advanced research projects for climate. Right? It doesn't have to be spun through military. This is not predominantly about money. It's predominantly about political will. The big investment that is being made is SpaceX's investment in making Starship and then lunar resource export a reality. Getting a sequence of missions for an L1 Sunshade demonstrator is like $25 million. We don't need to bring in political forces that don't need to be there.
Right.
I agree. Although I do feel like one of the greatest threats to the whole world's defense is climate change and
climate security, right? And
yeah,
at the end of the day, when we do have a global consensus on how to deploy SRM, it's going to be part of a new world order, which will replace the post-Cold War I order that is currently falling apart, right? So the powers that be are going to get together and they're going to make a deal, and it will have security dynamics, right? But that's above our pay grade, right? What we can provide is an honest and transparent conversation about what the engineering parameters of this are, and some early ideas on exploring governance, mostly in terms of just encouraging participation and open conversation. On the other end of that, it's going to be a political solution.
Great.
Well, I would comment that the Pentagon has been well aware for like a decade, more than a decade, that climate driven conflict is going to be a bigger and bigger challenge that it's going to face. And maybe it's not them directly that you talk to, or maybe it is because they do have their own planning. But just comparing the scenario of how much would have to be spent on a larger defense budget to deal with climate-driven conflict and creating security to counter that versus what it costs just to avoid all of the problem on a larger scale. The avoided climate damages that we could have from a sunshade, it's like versus the cost, just in economic terms, not human suffering, extinctions, all of that. It's like a factor of 2,000 or 5,000.
It's economically, it's a no-brainer. And you remind me of one of my favorite quotes from Jim Mattis when he was Secretary of Defense regarding cuts at the State Department. He says, "If you spend less money on diplomacy, I have to spend more money on ammunition." Like that's
Yeah.
It's a real trade, but it's above our pay grade.
Yeah, very good. Anyway, that's probably a good way to end it. Ross, thank you so much. Thanks for the work you're doing. Thanks for joining us on Climate Chat and telling us about this project, which I think many people, when they first hear it, it is truly just a science fiction idea, and you've made it sound far more doable and partly through the work you're doing. So thank you for that, and good luck.
Thanks for having me.
Thanks, everybody, and we'll see you next time. Bye-bye.
Bye.